my name is Michaela Douglas, and
I'm Cambria Matheson.
We are here today to discuss the difference in sound and difference in frequencies between Lithobates, Sylvaticus, and Homo sapiens.
As you can see from the diagram, lithobates produce sound across a small range of frequencies and tend to produce sounds at the lower end of the frequency spectrum. The data indicates that Homo sapiens produce sound across a broad range of frequencies and tend to produce sound at the higher end of the frequency spectrum. However, since Cambria's voice was used for this test, the results of this test will be skewed to the higher end of the frequency spectrum, because although Cambria is a contralto and her voice is fairly low for a female, the majority of males will still produce sounds at a much lower frequency. The duration of sounds for lithobates is considerably shorter than that of Homo sapiens. To help you better visualize the difference between them, here's a sonogram of the sounds produced by frogs, first at normal speed, and then slowed down. And here is a sonogram of Cambria singing at regular speed and slowed down.
La 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 la
There are 6 main parts involved in human sound production. There is the larynx, which is the voice box, and it is divided into the epiglottis, cricoid cartilage, thyroid cartilage, and tracheal cartilage down here. The pharynx, which is the throat, has 3 parts. The larynopharynx, the oropharynx, and the nasopharynx. The trachea, which is in this region here, connects the lungs to the throat, and the esophagus, which is the pathway for food and water, is another part involved in human sound production. And there is a spinal cord which runs along the spine, and the diaphragm, which is in this region here. Air comes out of the lungs through the trachea and into the larynx, which causes the vocal folds to vibrate, which creates the sound of the voice. The vocal folds are multi-layered folds that are continuous with the tissues of the throat. The front end of the vocal folds is attached to the cricoid cartilage, and the base of the vocal fold is attached to the tracheal cartilage. The vocal folds consist of 3 layers. There is an intermediate layer, which looks like rubber bands, a superficial layer that looks like fine threads, and the deep layer, which is arranged in tight bundles. All 3 layers are made up of collagen, and this structure allows the vocal folds to vibrate at many different lengths and produce a wide array of sound.
Dog has a few different ways of respiration, including through their skin, but only pulmonary respiration is involved in sound production. Pulmonary respiration involves lung ventilation and airflow through the glottis. This type of ventilation can be broken into expiratory and inspiratory. Expiratory, the glottis opens when the throat is in its lowest position. there is a slight pause with the glottis open and the throat down and the nares open. This is the point at which air is passed forcefully from the lungs and through the larynx and into the buccal cavity. This is done by contraction of the flank musculature. Inspiratory phase, there is a rapid elevation of the throat and the nares close. The glottis will remain open until the throat reaches its max elevation, and then it will close. Air is then forced from the closed buccal cavity into the lungs, which are then reinflated. The nares are only closed during the elevation of the throat in the inspiratory phase. After inspiration, the throat relaxes and the nares open. When the frog calls, it is a similar process to the inspiratory respiration. The sternoid muscles will contract and depress the mouth floor. With the nares open, air is able to be drawn into the buccal cavity and the nares now close by contraction of the anterior mandibular muscle. Through a series of muscle contractions of the posterior mandibular, interhyoid, hyoid, and geniohyoid muscles, the mouth floor moves upwards and forces the air to flow past the vocal cords, which causes them to vibrate and make sound. Unlike respiration, the glottis does not stay open during the release call, but will undergo a cyclic opening and closing, which breaks the sound into pulses. The nares will also close at the beginning of expiration to allow inflation of the vocal sacs. For a frog to call, it needs the following: a primary sound source, which are the vocal cords, a pump to provide sufficient air pressure to vibrate the vocal cords. This is done through muscle and hyoid movements, a valve to regulate airflow, which is the glottis. The most obvious difference is in the sternoid muscles, which control the mouth floor movement. This muscle is either activated in the internal between two elevations of the mouth floor, along with the elevator activities, or during both phases of buccal movements. All terrestrial frog calls evolve from respiration.
The main reason why both species produce sound is to communicate with members of the same species. Speech is the main way through which Homo sapiens communicate. Our sense of smell is fairly weak, so we can't communicate through the use of pheromones like many other species.
Hey, guess what I'm trying to say to you through smell?
Go die?
Yeah.
I've got
Homo sapiens also do not evolve the greatest capability of communicating through movement and body gestures, body language.
Are you trying to be a bird?
No, I'm trying to tell you look good today.
Another reason as to why Homo sapiens are so vocal is that we are extremely social creatures that live together in packs and need to communicate to survive. Communication also is essential for our very well-being, because communication plays a critical role in development, ensures a good quality of life, and keeps us from basically going crazy. Lithobates have a narrow range of sounds and only have two main calls: release and mating. Because they don't really need to communicate, because they're solitary creatures. They live their whole life cycle without much real contact with the same species, except to procreate. And while sound is used in the attraction of mate, they also communicate through pheromones. The release call is used when a male or female are clasped by a sexually active male. A sexually active male frog may grasp another male frog, since frogs cannot tell the difference between male and female just by appearance. If the sexually active male grabs another female, a male or a female who is not ready to mate, the individual will give a release call so the sexually active male knows to release the individual. The main purpose of the mating call is for a sexually active male to attract a sexually active female. While this call's main purpose is to attract a mate, it can also be used for territorial spacing and congregation of animals at breeding sites.